Hello and welcome to this video on simplifying sums and differences of radical expressions. Today we are going to look at radical expressions and we're going to be adding and subtracting them. Just kind of recapping your knowledge on radical expressions. Here I have an example of how we can simplify a radical expression, and this is asking what's the cubic root of 16. And you may realize, hey, 16 is not a perfect cube. However, 16 does have a perfect cube within it, right? And that would be 8. 16 is 8 times 2. So I can break down 16 to be the cubic root of 8 times the cubic root of 2. Well, the cubic root of 8 is 2, so I can simplify this, and we just get 2 cubic root of 2. Another example would be with square roots. Square roots, if I have root 60, I can break down 60 to identify a perfect cube, and that would be 4 times 15. So I have the square root of 4 times the square root of 15. Well, if I simplify the square root of 4, that is just 2 root 15. And our third example, what is the perfect cube of 81? Well, 81, that is 3 to the 4th power. So it's the cubic root of 27 times 3. And 27 is a perfect cube, and that simplifies down to 3. So we're going to be utilizing this skill in today's lesson. So here's the concept of the lesson. When we're adding and subtracting radical expressions, only like terms can be combined, and that's very important. Just like when you're adding and subtracting variables, only like terms can be combined. So what does it mean to be a like term? Well, you have to have the same index, and you have to have the same radicand. Now remember, index is just kind of like the power of the expression. So here I have like terms, right? They're both square roots here. Same index. Okay, so I can combine them. And here I have the same index. However, this is an unlike term because you also have to have the same radicand. So pay attention here. Notice, right, 2 and 3 are not the same number, so therefore I cannot add them. Okay, here I have root 2 and root 2. So if I have 3 root 2, I can subtract 5 root 2 by just subtracting the coefficients. Okay, and you almost treat the radical expression like a variable. So 3 take away 5 is negative 2, and this is root 2. Here's another example of like terms. I have the cubic root of 5 and a cubic root of 5. So 4 cubic root of 5 plus 9 cubic root of 5. This is 13 cubic root of 5. Now, we also have to simplify radical expressions and just make sure they're in simplest form. And there are certain conditions that we have to make sure that we adhere to. Number 1, the radicand of a nth root has no factors of an nth power. So here, for example, 2 root 3, this is completely simplified because the radicand does not have a perfect square within it. Square root of 12 has a factor of 4 within it, which is a perfect square. Okay, so we have to continue simplifying this. Number 2, the radicand is not a fraction or a decimal. Here I have a fraction, but notice the radicand is a whole number. We cannot leave expressions as a fraction within our radicand. Number 3, there are no radical expressions in the denominator of a ratio. Mathematicians were finicky. We hate having a radical in our denominator, so we go ahead and we get rid of this. This is not today's lesson, but we'll cover that coming up. Number 4, like terms have been combined. So you are in simplest form when you have added all like terms. Notice here I have 4 root 2 plus 3 root 2. Well, you have to combine these to be 7 root 2. Here are the first sets of examples that we are asked to simplify. Now I have 3 square root of 32. Well, 3 square root of 32, this is 3 times the square root of 16 times the square root of 2. And 16 simplifies to 4. So 3 times 4 times the square root of 2. This is, and I actually like to put my equal signs here because they're all equal, 12 root 2. Okay, working on cubics. Now this can be tricky. So if you struggle with cubics, what I suggest doing is just making a chart and making a kind of list. 1 cubed, that's 1. 2 cubed, that's 8. 3 cubed, that's 27. 4 cubed, that's 64. 5 cubed, that's 125. Okay, so these are the ones that should just automatically be embedded in your head, and you can keep going if that helps you. And I recommend flashcards. Flashcards tend to help out too with this. But I have 4 cubic root of 250. So I can simplify this. This is 4 times the cubic root of 125 times the cubic root of 2. Well, the cubic root of 125 is 5. So I have 4 times 5 times the cubic root of 2, which is 20 cubic root 2. Okay, and these would be our final answers. All right, now we're going to talk about our objective here. It says simplify sums and differences of radical expressions. I'm gonna add like terms, subtract like terms. Okay, now here I have 9 plus 6 root 2, take away 11 root 2. These are like terms, and how do I know that these are like terms? Well, their index is the same. They're both square roots, and their radicand is the same. So I can combine them. I have 9 plus 6, take away 11. That would be minus 5 square root of 2. Moving on to the second example. Here I have 2 root 6, take away root 6, and then notice how I have a 1 root 5 and then another 1 root 5. Okay, so this would be 2 root 5 plus 2 take away 1 is 1 root 6. Okay. Now, a question that pops up a lot is, can I combine these? Am I able to combine these, root 5 and root 6? And the answer is no, because again, they're not the same radicand. Okay. All right, moving right along. Here, now notice I don't have any same radicands. I don't have any like terms. So what we're going to have to do is reduce. I can rewrite 18 as the square root of 9 times the square root of 2 minus square root of 4 times square root of 2. So this is 3 root 2 minus 2 square root of 2. 3 take away 2 is just 1, and so our answer is the square root of 2. Be careful. They will try to set you up with these problems. They try to use your recognition of things like this, and they will want you to simplify that to be 2. Okay, so be aware. I think it's important to kind of remember to identify. This is my terrible drawing of a light bulb. I don't have yellow. I guess I could make yellow. But this is a light bulb. So identify index. Always, always, always identify your index. Okay, know what you're working with. So like in this problem here, I have square roots. Okay, so my index is 2. I'm working with perfect squares. Oh, I don't want to go that far. Okay, so if I have negative 5 root 24, I want to simplify this. This would be negative 5. And I want to kind of break down the perfect squares. So this would be root 4 times 6 minus 5 root 6 plus 2 square root of 54. That's a perfect square would be 9 times root 6. And sometimes too, if you don't know like what factors, how to break this down, they give you clues. So here I see root 6 there. Okay, so I know, hey, maybe if I break this down, divide by 6. Okay, so now I can simplify from here. Negative 5 times 2 root 6 minus 5 root 6 plus 2 square root of 9 is 3 plus root 6. Okay, so this is negative 10 root 6. Take away 5 root 6 plus 6 root 6. Okay, here we get negative 15 root 6 plus 6 simplifies to be negative 9 root 6. Okay. At this point, I have a couple more slides of examples. I recommend pausing this video and going to Google Classroom, looking at the practice problems that I have posted. The slides alternate, so you'll get a slide with just the problem, and then the next slide, if you scroll down, it'll have the solution, so you can check your work. I recommend pausing here, trying some of those practice problems, and then coming back when we get to the next ones. All right, now same type of problems, except here we're going to be working with cubic roots. And again, these can be kind of tricky if you're not familiar with the values. So again, make a list: 1 cubed, 2 cubed, 3 cubed, just to kind of gain familiarity with, I don't know why I wrote 3 to the 4th, gain familiarity with some of those factors. Okay, so cubic root of 192. In this example, I'm going to break this down. This is the cubic root of 64 times the cubic root of 3. And that one you might have to play around with some calculators to help you identify it. Minus 3 cubic root of 81. And 81, I know that is 27 times 3. Okay, and I have an index of 3 with a radicand of 3. So cubic root of 64, that's 4. I don't want to forget my equal signs. Minus 3 times 3. Times the cubic root of 3. So this is 4, take away 9, and that is negative 5 cubic root of 3. Okay, and here we have our last example, 5 cubic root of 32. I want to go ahead and break that down, what perfect cube is in there. That would be 8. So this is 5 cubic root of 8 times the cubic root of 4. Minus 375, that should pop a 125 right into your head. That's 5 cubed. So cubic root of 125 times the cubic root of 3. Hopefully I can fit this. Plus, here I have the cubic root of 108. That one is cubic root, let's see, I believe that's 27 times 4. Okay, times cubic root of 4. And after we simplify, this is 5 times 2, cubic root of 4, minus 5 times cubic root of 3, plus 3 cubic root of 4. Okay, so I have 10 cubic root of 4, and I gotta hurry rush this, plus 3 cubic root of 4. Okay, and that gives us 13 cubic root of 4. and minus 5 cubic root of 3.